Hello everyone, welcome back to another video, and today I'm gonna be doing some math. Okay, this is going to be the first math video on the channel, so we're gonna cover up the harmonic addition theorem. What does it actually says that though? Well, it states that if you see an expression in terms of like this, a sine x plus b cosine x, where x is actually the same, we want to actually rewrite this as capital A as the constant times cosine of x plus some angle theta. So you're gonna actually have to expand this, okay? So don't forget we have parentheses right here, okay, because this is a multiplication sign. We're gonna expand this, so we're gonna get cosine x cosine theta minus sine x sine theta. So the next thing you wanna do is just multiply, okay? Multiply everything, capital A times cosine of theta, okay? Let's actually group the common things in the front as the constant times cosine x, okay? Minus capital A sine theta sine x, okay? Because no matter what, you can actually switch the order, okay? Switch the position on the thing. It's going to be the same. So it's going to be the same as I sine x plus b cosine x. Yeah, I'm pretty much on far. Okay. Notice that this and this matches. This and this must match, okay? So A is equals to negative capital A sine theta, and B is equals to capital A cosine theta. So now what though? We have two different variables rather than x and others. So yeah, rather than x we have two additional variable that we're actually going to isolate. We got capital A and theta. So we're going to actually isolate the theta first. So we're going to actually divide the A and B together. So A over B, okay, will be equals to negative capital A times sine of theta over capital A cosine theta. This now will cancel. We'll have a negative tangent theta. So this will conclude that tangent theta will equal to negative A over B. So theta will be equals to inverse tangent of negative A over B. So this is the one. That's the first one, okay. Now second one, we're gonna actually isolate the A. So why don't we just square the A, okay? So we know that this, why don't we just square this, and also we're gonna square that. We're gonna also square this, and we're gonna actually square that. So, and actually add them up, okay? So A squared plus B squared is equals to A squared sine squared theta plus capital A squared cosine squared theta. Now we can actually factor the capital A squared. We get capital A squared times sine squared theta plus cosine squared theta. Now the good thing is that this equals 1. So yeah, we just have A squared is equals to capital A squared is equals to A squared plus B squared. Okay, so A is going to be square root of A squared plus B squared. So A sine x plus B cosine x equals to the square root of A squared plus B squared times cosine of x minus, oh, I've also forgot to mention that this thing right here can also be rewritten as theta is equals to negative inverse tangent of A over B, because tangent is an odd function. We can actually bring the negative to the outside, okay? And keep in mind like that though. So this is the negative inverse tangent of A over B. There's a condition though. There's a condition on this. But we can also use negative A squared of A squared plus B squared times the rest is the same, okay? but just the same, the sign, okay? The sign alternates if b is less than 0. If b is equals to 0, anything over 0 is not divine though, so yeah, don't actually do that. So let's say that you're given a problem, okay? Okay, example. Let's put this thing into action, okay? So, find all the x such that sine x equals to cosine x. I know what you're thinking. Well, it's just actually x is equals to pi over 4 plus 2 pi n, and n is where n is an integer, okay? And actually x equals to 5 pi over 4 plus 2 pi n, where n x an integer. Ah, yes, this is our the solutions, okay? Yeah, you know that's the deal. But we know the deal. I like to do things that gets it into a whole different level. So we're gonna use the formula, okay? So first we move the cosine to the left side, so we get sine x minus cosine x is equal to 0. And this one, okay, it's negative, it's less than 0. The b is less than 0, so we're gonna use the other one, okay? So negative of this, so negative the square root of 1 square, because the coefficient is 1, it's not written there, it's 1, plus the minus 1 square cosine x minus inverse tangent of 1 over minus 1, okay, is equals to 0. So negative square root of 2, okay, 1 plus 1 is equal to 2, cosine of x minus inverse tangent of negative 1. This equals to 0. So negative square root of 2 times cosine of x. This, okay, inverse tangent of negative 1 is equals to negative pi over 4. Okay, so inverse tangent's domain exists on the interval, the range from negative pi over 2, okay, to pi over 2. Okay, so the range. So yeah, I feel like it only existed only on these two parts. This part sadly does not. So yeah, we can actually write this as negative pi over 4. Yeah, we can actually write as plus. Yeah, plus pi over 4 is equals to 0. So we can just yeah, put this into action. Okay, cosine of x plus pi over 4 is equals to 0, because yeah, we divide negative square root of 2 on both sides. So now we're gonna find this one right here. Look at the equation. So cosine is 0 when it's here and also here. It's actually on where it's on pi over 2 and also 3 pi over 2. Yeah. Alright, so leaving this thing right here. Okay. So let's put this thing into action. Cosine of x. Sorry. So yeah, that's when cosine of x plus pi over 4 is equals to cosine of pi over 2 plus 2 pi n, where n is an integer. And it's also when cosine of x plus pi over 4 is equals to cosine of 3 pi over 2 plus 2 pi n. It's 3 though, where n is an integer. Well, so let's solve the thing. So yeah, we're gonna have to set the inside of 2 equals, so x plus pi over 4 is equals to pi over 2 plus 2 pi n, where n is an integer. So x, okay, minus pi over 4 on both sides, we gotta get pi over 2 minus pi over 4, which is pi over 4, plus 2 pi n, where n is an integer. that's the first one. Moving on to the second one. That's when x plus pi over 4 equals to 3 pi over 2 plus 2 pi n, where n is an integer. Okay, so x 3 pi over 4, 2 pi over 2 minus pi over 4. You just calculate that, you'll get 5 pi over 4 plus 2 pi n, where n is an integer. So the solution are basically the same from the one that you actually used in the first one, that I actually got in the first one. So yeah, that's basically that's an example of using the harmonic addition theorem. Okay, so yeah, thanks for watching. See you guys in the next video about maybe another trigonometry, maybe some other math, or maybe gaming videos. Stay tuned, guys.